What's up, guys? So today we'll be doing a tutorial on the product rule. If you want more of an explanation on the product rule and more examples, refer to the video on the product rule. I'll be just doing some example questions in this tutorial like always, and yes, I hope you guys find this helpful. So let's get into it. So our first example, we're given a function y is equal to 3x squared plus 2 in brackets times brackets 4x squared plus 6. Now we can take the derivative of this by distributing this out, multiplying it all out. But since this is a video on the product rule and, using it to find derivatives, we're going to be using the product rule. So what I'm going to do is, I'm going to take a look at this function, and what I see is two separate, you could think of these as two functions being multiplied together, both, things in each bracket, each set of brackets. So what I'm going to do is I'm going to call this u, and I covered this parameterization in my product rule video, but essentially u is just another way of, it's a parameter. It's another way of representing this function. It's just saying that, this whole thing we can just say this is just some letter u, or u could just mean like f of x. If you want to call this first bracket, everything in this first bracket f of x, that's basically just equal to u. So just pretend u is kind of like a function. So basically u represents everything in the first set of brackets, and I'm going to say this is v, and v represents everything in the second set of brackets. Now, what is y prime then? Well, what does the product rule tell us? Well, the product rule tells us take the derivative of one of the functions, multiply by the other, then add the derivative of the other function multiplied by the function whose derivative you took in the first term. So what do I mean by that? Well, I mean take the derivative of the function in the first term. So first we take the derivative of this, then we multiply it by this, then we add. Now we take the derivative, and I'm going to use a different color. We take the derivative of this, so now v prime, and we multiply it by the original function, this, so just u. So what we see is that it's kind of like we kind of alternated. So we took the derivative of this term first and multiplied it by this term. Then we added, and we did it the other way around. We took the derivative of this term and multiplied it by this term. And we keep doing that depending on how many terms we have. In this case, we only have 2, so we only have to do it basically 2 times. So let's finish this off. Use black. So y prime. So what is u prime? What is the derivative of this first term u? Well, what is the first term? Well, it's 3x squared plus 2. Well, what's the derivative of that? Well, the derivative of the constant 2 is 0, so we just need to deal with that first part. So the derivative of 3x squared, well, using the power rule, we bring that down, and that just turns out to be 6x. So we're just going to put that in brackets. It's very good to do that if, you're just starting out, you're just practicing, and you don't have a lot of exposure to the product rule. It's very good to put your terms in brackets. And it's especially good to write out your product rule. So let's continue. So we got y is equal to 6x. Well, now we just, multiply it by v. And what was v? Well, v is just 4x squared plus 6. So there we go. We're done our first part of our derivative. So now we add, so plus. Now it's v prime times u. So what is v prime? Well, what is v? Well, v is this right here, 4x squared plus 6. And v prime would be the derivative. And in this case, we have a constant 6 here. And the derivative of that is 0. And we have so we only got to deal with this first part, which is 4x squared. And using the power rule, well, the derivative of 4x squared, well, what is that? Well, it is just 8x, put that in brackets, and multiply it by u. And what is u? Well, it's just 3x squared plus 2. We're done. We got our derivative. Simple, easy. You just got to know, identify, two separate functions here and see that they're being multiplied together. Assign a parameter, which is a very important thing. And just write out your product rule and just do as the product rule says. And in this case, it says, u prime v plus v prime u, because we got two functions and we assigned parameters u and v to them, and we just took the derivative. So let's go into our second example. Well, example 2. Example 2 says we got some function. We got y is equal to 5x. Gotta make the bracket nicer. There we go. 5x cubed plus 2x times. I'm just gonna. No, that shouldn't have happened. Sine x. So that's what we got. We got in brackets 5x cubed plus 2x times sine x. So we want to find y prime. We want to find its derivative. Well, again, let's assign parameters. So we know that we use the product rule when we have two or more functions being multiplied together. And here we can see we got two functions being multiplied together. We got this in brackets here times by this function. So we got two functions here, and we can assign parameters as we did before. We're going to say this is u, and we're going to say this is v. So let's write out our product rule then. So what is our product rule? Well, we take the derivative of u first, multiply by v, plus, now we take the derivative of v, and multiply it by u. So, each function gets its own turn to have its derivative taken. So let's do as the product rule says. Let's just, follow the instructions. So what does it say to do first? Well, it says take the derivative of u. I'm gonna use a different color. So what is u? Well, u is 5x cubed plus 2x. What would the derivative of that be? Well, the derivative of that would be, well, using the power rule, we'll bring down that 3 for our first term right here. So we got 15x squared plus, now we get our second term. Now we'll bring down that 1 that we don't write, and we just get a power of 0 on x. So we just get 2. And now we multiply by v. Well, what's v? Well, v is just sine x. Now, next term, now we're going to be here now. What's v prime? Now we take the derivative of v, and what is v prime? What's the derivative of sine x? Well, it's cosine x. And that's times u. And what is u? Well, u is just this whole thing right here. So let's write that down. 5x cubed plus 2x. We're done. Easy, simple, just doing as the product rule says. So let's move on to our last question. Well, what's our last question? Well, our last question is a little different. It says y is equal to 1 over x tan x ln x. So what we can see here is that we got not the product of two functions, but the product of three functions. And students usually are very used to dealing with the product of two functions, and when they see three functions, they get a little confused. And there are multiple ways you could do this question, but we're just gonna treat this as three separate functions. We've got one right here, one right here, and one right here. We've got three separate functions. We're gonna think of it like that. There are other ways you could do this question and find the derivative, but we're just gonna think of it like this. So, well, if you have three functions, well, how do we parameterize this? Well, we can call this first function, I'm gonna use a different color. We can use this first function as u. We can call the second one v, and we can just call the last one w. So it's third parameter. And if you watch the product rule video, I go over this in more depth. But what we do is that, recall that each function gets its own turn to have its derivative taken. So first u prime times vw. So we take the derivative of u prime and multiply it by the other two functions, and we do not take their derivatives. Then, since u prime had its derivative taken, now it's v prime's turn. And now we multiply it by u and w. Now the last function left is just w on its own. So we got u, v, and we got w prime. Now, we got our instructions right here telling us what to do. So let's do as it says. So let's take the derivative. Let me use a different color. Let's take the derivative and find u prime. Well, what's u prime? Well, u is 1 over x. And we can write 1 over x. We can write 1 over x, x to the negative 1, right? So let's take the derivative using the power rule. So we bring down the negative 1, so we get negative x to the negative 2 and put that in brackets. And multiply it by v and w. So what do we get? Well, we get tan x ln x. So we're done this first part. Let's go into our second term. Well, what does our second term say? It says u, which u is just 1 over x, times by v prime, and v is tan x. Well, what's v prime? Well, I have covered this in my derivatives of trigonometric functions. However, v prime, the derivative of tan x, is secant squared x. This isn't very good. Secant squared x. So that's our v prime. And what's our w? Well, w is ln x. So now we're done our second term. We just got one more term left. Okay, so what is u? Well, u is just 1 over x. What is v? Well, v is just 10x. And now we got to take the derivative of a ln x. Well, and ln x is w. The derivative of ln x is w prime, and w is equal to ln x. So what is the derivative of ln x? Well, the derivative of ln x turns out to be 1 over x. And this is just one of those derivatives I'll probably cover in a different video. But it's just one of those derivatives you just got to know. And it's not that hard. It's just 1 over x. So there we go. We're done. So what a big takeaway from this video should be, understanding the product rule, following, writing it down, making sure you get it, and just knowing, your other derivative techniques, such as knowing your trigonometric functions, your power rule, and you might come across, other ones, inverse trig functions you might need to use. You might get a question like x tan inverse tan x. Like, how do I take the derivative of that? Well, you're realizing you need to use the power rule here is the first step, right? And then you got to know how to take the derivative of inverse tan x. And I haven't covered that yet. I'll be covering that in implicit differentiation. But as you can see, that's very important, these other skills, because the product rule and the quotient rule are both, used a lot. They require the use of other rules within them. So as you see that, we use the product rule here, right? But within the product rule, we had to use the power rule. We had to take the derivative of our trigonometric functions and our logarithmic functions. So you're using rules within rules, kind of. So that's a big takeaway from this video, is you got to be real sharp with your other rules. The product rule is just one of these vast rules, but within it, you're going to be using other rules, definitely. And, you'll be using the power rule, definitely. And you'll be using other ones, definitely as well, because, the power rule is like this broad rule that's telling you, if I have a product of functions, how do I go about, splitting it up and taking the derivative? But in order to take the derivative of each term on its own, you have to use other rules. So thanks for watching. I hope you guys, got something out of this. Like and subscribe. Check out my new videos. I'll be putting more videos up on, I think my next one will be one on the quotient rule. We're doing a tutorial on it. So thanks for watching.